Alright, hell yeah. So we're going to add vectors together. This is engineering statics. This is Hibbler. So cool. Alright, we're going to go over this. This is the cool technique that I like to do. So a vector is always going to be your hypotenuse, and the parts of the right triangle are going to be its components in the vertical and horizontal direction. So I like to, hey, this is 30. Let's just divvy it up, into 3. I either divvy it up into half or like 3 parts just to get kind of an estimation. So heck yeah, it looks like this length is approximately, 20. If this is 30, there's 2 of them. So heck yeah, I'm just going to say this length is 20. Now down here, I don't know, maybe maybe it would be 25. So that's kind of my first guess. Over here, kind of doing the same thing, just kind of divvy it in half and like, hey, is this length equal to that length? Well, no, so maybe divvy it up into thirds, and you could even divvy it up into a quarter. So it definitely looks more than a quarter, but if just for a rough guess, I'm just going to call this 5. And sweet, so now we can just very easily kind of add these up. We have 25 that way, and then 50 this way. So we're going to have a result of 25 that way. Cool. Oh, and then the other aspect of this is, I totally forgot, like here, anything under 30 degrees, or 30 degrees and under, like this is 20, so this component right here is just 20. This length is basically the same as that length. Okay, hell yeah. So we got 25 in the horizontal direction. Now the vertical direction, we got 20 up and then 20 down. So those are going to cancel. So we're going to have 0 in the vertical direction. Cool. So now we know our magnitude. Our magnitude is going to be approximately 25, and our angle is going to be 0. Okay, sweet. So now we're going to go kind of do a better approximation. And that was kind of just like looking at the vector and kind of breaking up into parts. That was kind of the estimation technique there. Here's the second estimation technique. So if I have now we're still staying just real rough. So this vector, I'm just going to say it's about 45. I don't care if this side's bigger than this side. We'll get into that for our second guessing technique. But what I do know about a 45-degree triangle is, hell yeah, the components are about 70%, 0.7. So I'm just going to multiply 7 by 3. That's going to be 21. So cool, I'm just going to say this side is 20, this side is 20, just from that perspective. Again, small angles, like, hey, this length of the hypotenuse is basically the same length as the cosine component. So I'm going to say this is 20. Cool. And I'm going to say this is 5. So kind of same thing. We're going to have 20, 50. So we're going to have 30 in that direction. And then 20 and 20, those are going to oh, I'm sorry. And did I mess up here? Because we have 25 in this direction and 5 in this. So we got 30 going this way, 50 going that way. So yes, this should be 20. Hell yeah. So we have a magnitude of 20 and an angle of 0 from that first guess. That's the issue with guessing. Sometimes you get rushed and you can make mistakes. But hell yeah. So we have 20 and 25. So yeah, this guess is going to be a magnitude of 25. And we have 20 minus 20. Still no vertical direction for a component, just a horizontal, so our angle is 0. Okay, hell yeah. So now we're going to kind of improve upon our guess. And we're gonna look at this one first. Anytime you get a 3, 4, 5 triangle, like change this to 10, and this to 6, and this to 8. It comes in, well, two schools of thought. You know what I mean? You could multiply this by 6, and then you're going to get 180. You know what I mean? Obviously, you're going to, take away a 10. So, because it's basically like saying, hey, I'm going to multiply, if I say this, 0.6, 0.8, and 1, this is equivalent to, it's basically like saying 60%. 80%. So if you're good at, multiplying 0.6 by 30, but I think just, what I mean? And then the other thing is like, hey, never forget, if your hypotenuse is 30 and you're guessing, well, this has to be maybe about 15 or something. So if I do 3 times 6 and get 18, cool. I think it's 18. I don't think it's 1.8, and I don't think it's 180. So we can do the same thing here. Let's say we're doing 8 times 3. This is 24, right? Because it's not 240, it's not 2.4. Cool. So we got 18 and 24 on those two components. All right, so let's see. Are we going to improve upon our guess here? Because that was precise. If we got a 3-4 triangle, this is exact. Now, if you have 20 degrees, hey, you at least can probably estimate the sine component. So the sine component, because we know 30 degrees, the sine component is going to be 0.5. So you can use like a factor label method. I'm just going to say like that this is how this is the proof that I use. I'm going to say it's a small angle, even up to 60 degrees, or 1 radian. And I'm going to say 1 radian is approximately 60 degrees. So if this is the radius of 1, I'm going to say this length, the cosine component, is 1. So then if I get something like 30 degrees, or 1/2 a radian, I'm going to say, hey, this component's 0.5. Radius is still 1. So when I say, it's the small angle. It says sine of x is equal to x when you're using radians. Cool. So if I have, but what happens when you get degrees? Because if I have 30 degrees, how would I get 0.5? I would divide by 60, right? You know what I mean? That would be a little equation, 30 divided by 60. And if I had 1 radian, if I had 60 degrees and wanted to find the cosine component, well, I would also just divide by 60. So cool. All right, so we're going to do that. We're just going to take 20 divided by 60, and that's 1/3, or 0.33. So, that's the ratio that we get here. So we get 1/3 of 20. That's going to be 20/3, or 6 2/3. Cool. So we got 6.6, or 6.7. I'm just going to do 6.7 for this term right here. And so we have 50 minus 6.7. So 50 minus 6 is 44. So it's going to be 43.3. So cool. So we got 43.3 going that way. We're also going to minus, subtract 24. Doesn't get any easier. But we got 9, and then we got 19.3. Sweet. So we got 19.3 this way. Hey, we're getting pretty accurate probably. And then, hey, do you want to get more accurate on this? I could just say still it's 20. But, you know what I mean? Things to know. The first one to know is if you get like a 30-degree triangle. Your cosine component is going to be 0.866. That's that one and 45 degrees of 0.707. You can memorize that to just 3-digit accuracy. Because even the next number here is like 1,4. And the next number here is like 0.025. You know what I mean? So it's really accurate. All right, so 70 degrees. You see a lot of problems with 20 and 70. You know what I mean? And well, if you're working up from 60, so this is basically, I think I like to think of the cosine component in regard to the larger instead of the sine. Instead of cosine 30. I like to think of it as kind of the sine component. I don't know why I like to do that, but yeah, the sine component of 60 is going to be 0.866. The sine component of 65 is going to be 0.9. You know what I mean? So it goes to 0.9. Sine of 70 is 0.94. You know what I mean? And I don't know how you're going to remember that, but you know what I mean? Sine of 72, that's not going to be really helpful. That's 0.95 if you know, anyway. So, hell yeah. So I guess I just know that the sine of 70 is 0.94. So hell yeah. So we have, I like to look at this as 6 points from 100. So if I take the hypotenuse of 20 and then move the decimal place, this is This is 10%. If I take 10% of 20, I get 2. If I take 1%, I get 0.2. So that's 1%, and I need to reduce this by 6%. So I'm going to reduce it. 2 times 6 is 12, but we have a decimal there, so it's going to be a reduction of 1.2. So this 20 becomes 18.8. Hell yeah. So let's see where we're at. So we're 19.3 that way. We have exactly 20 this way, and we're going to be 20 minus 18.8. So is that right? Yeah, this was going to be 18.8. This was 20, and sweet. Now, is that right? Because the other way to do this is like, hey, take 30 and take 3/5 of it. I didn't mention that. So instead of doing this 60% or making this a 6 and this an 8, you can just take, this component is 3/5 of 30. So if I do that, that's going to be 90/5, and that's going to be 90, 180. You know what I mean? No, I mean 18. Sorry about that. So holy Toledo. Yeah. So we have 18. That was an earlier guess. We have 18 and 24. I used the 24. So now we're taking 18 minus 18.8. Cool. So we're going to be a negative 0.8. And so our component's going to be 0.8 down, and then 19.3 this way. Cool. So what's our full magnitude? Well, I kind of look at this ratio here. This ratio here is basically 1 in 20. So with hypotenuses, this is fun to guesstimate as well. So if I have two equal components, hey, you know what I mean? I know that one and not that one. So this hypotenuse is going to be 1.4. That's going to be the ratio. 1.4 times the largest number. I always just think, if I have a right triangle, choose the largest number, and then kind of use this idea that you're going to multiply the largest number by like a factor. This is going to be 1.4, or you could think of it as 40% increase. And that's because the square root of 2 is 1.414. So, yep. So you're going to take that number and multiply by 40%. Cool. So if this was 3/4 and this was the larger one, and this was 3/4, then you're going to actually just multiply by 25%. If this is half, it drastically goes down. It's only 10%. And then after that, probably just don't care. You know what I mean? And this, if you want to care just a little bit, you know what I mean? At 1/3, it's going to be 5%. At but that's even at 1/3. At 1/4, it's going to be 2.5%. And then at that's it. That's even if this is 1/4 of the larger number. You're still your increase in the hypotenuse only increases. It's going to be a multiple of the larger side times 2.5. So hell yeah, like 1 in 20, and you do this by like, hey, the square root of 1. Let's see, 1 plus 1 divided by 20 squared. So that's going to be. This is going to be not even 1%. It's going to be 1/10 of a percent. So if I take 19 and go, that's 1%, 0.193. I'm going to add 0.0193. So, you know what I mean? So my value here is going to be 19.3193. Who cares? You know what I mean? 19.32. So I get 19.3 is my magnitude. How about the angle? You know what I mean? Because this magnitude doesn't change, because the hypotenuse, like this doesn't drive very, very much for the increase in this hypotenuse. You know what I mean? Small angles, hell yeah. This component is the same as the hypotenuse. But it doesn't take this value to make quite a bit of angle. So the ratio here that we got is 0.8 divided by 19.3. Kind of what I see here is almost 1 divided by 20. And that's what I'm going to use. I'm going to say this is 1/20th. Is it going to be more than that? I mean, because we increase this, but we also increase this. So sure. Let's say it's just 1/20th. And we need to know how to get the degrees. Well, just right back here, we took radians. You know what I mean? We took this ratio. I mean, I'm sorry. We took 30 degrees and divided by 60. You know what I mean? we took 20 degrees and divided by 60. That's going to be the ratio of 1/3. That means that this is a third of that, and we did that at the beginning. You know, you divvy this up into 3, you're like, oh, I see that. I see that this length is basically this length. That's what I'm saying. So how do you go from the ratio? Let's say I knew that ratio was 1/3. I see it, 1/3. What's this angle? Well, I take that 1/3 and then multiply by 60. Sweet. So I'm going to have 20. So this angle would be 20. Let's do the same thing. We have a ratio of 1/20th. We're going to multiply by 60. Hell yeah. Zeros go away. We got 6 divided by 2. That's 3. So hell yeah. So we have an angle of 3 and then a magnitude of 19.3. So sweet. We're going to look this one up and see how we did. Oh, actually, we can't look this one up. Yeah, this one's a starred problem. It's not in there. So let's just use our calculator now. Hell yeah. So to use your calculator, it should be pretty straightforward. We don't have to use sines and cosines when you have a 3, 4, 5. Or any time that you have this, like even if you have a 30-degree triangle, well, hell yeah, this is going to be 1/2. This is going to be the square root 3 divided by 2, and this will be 1. Sometimes you'll just get it like this, you know what I mean? Let's say this is 2, this would be 1, and this would be square root 3. Doesn't matter if you're trying to find, like, hey, this component, it's going to be this divided by that multiplied by your hypotenuse. Let's say this was 20. It's going to be 20 times square root 3 divided by 2. Always the side divided by the hypotenuse. Sweet, so let's do it. So we're going to have 30, and then we're going to have, which direction we want to go? Want to go in the horizontal first? So we're going to have, we'll do negative 30, so we don't forget about that, and then just 4/5. Sweet. And then we're going to add 50, and then we're going to also maybe subtract this. It's going to be 20 minus 20 sine of 20. You know what I mean? So we do have a considerable component. Hell yeah. And then I'm just going to store that as alpha I in my calculator. So we have a 19.15. How did we do? We got 19.3 without using our calculator, just kind of using kind of the percent. It's fun to use percentages and kind of knowing what these are. Sweet. And definitely I really enjoy, if I know two sides of a right triangle, kind of using this 40, 25, 10 method to kind of estimate what the hypotenuse is going to be. And then just knowing that if it's less, if this is less than half, you can almost just say, who cares? All right, because there's going to be hardly any increase. All right, so that was the I component. How about the Y component? We're going to have 30, and then we got 3/5. Sweet, and then we're going to subtract. What we have here is we're going to have 20 cosine of 20, or we do the sine of 70, you know what I mean, for that component. Because, yeah, I don't know what the cosine of 20 is, but I definitely, when I think of this 0.94, that ratio, or if I think of 65 being related to 0.9, I know that because the 60-degree, the 60-degree part of a triangle, or the sine component, is going to be the, if I'm staring at 60 degrees here, this is going to be the longer side. So yeah, just thinking of it in terms of sine, I can definitely remember 65 is 0.9, 70 is 0.94, 72 is 0.95. I don't know. Well, oh yeah. And then if you go up to 80, hell yeah, you get 0.966. And it kind of, and then who cares? Then you're just basically one, get on with life. But hell yeah, because 60 is 0.866. So there you go. You go from 0.866 and then maybe finish at 0.966. Anything bigger than an 80-degree. I mean, if you got something that's 10 degrees, and this is your hypotenuse of 100, you better be calling this 100, because it's just like what are you doing? You're splitting hairs. I guess you could call it 98. But yeah, it's going to be about 2%. But that is another one to know, that hell yeah, if you got about 10%, 10 degrees or 11 degrees, 10 and 11, I think it's 11 degrees is 98. So hell yeah. Anyway, all right, let's do this. So we have, what do we got? So we just got the vertical component of this, and then we're going to, that was an addition, that was adding. We're going to subtract it from the vertical component of that. And hell yeah, we're going to store that as alpha j. So sweet. So then the magnitude is alpha I squared plus alpha j squared, just those components, and we get 19.176. So we did pretty good at 19.3. If we store that as x and minus 19.3 divided by 19.3 times 100. Hell yeah, we're less than 1% error with our techniques. So that's pretty sweet. How about the angle? We're going to go inverse tangent of alpha j alpha I divided by alpha I, and it's going to be in the negative direction. So if here was my negative 0.8 and this was 19.3 basically, then here's my angle. And so the tangent of this, I'm just going to put a negative here. It's going to be tangent of this angle is going to be negative 0.8 divided by 19.3. So the angle itself is going to be the inverse tangent of negative 0.8 divided by 19.3. And so if we do that, we get an angle of negative 2.37 degrees. So our estimate of 3 degrees was pretty close. So that was pretty sweet. All right, so I've been enjoying going over some of these guesstimation techniques. I don't know. I think they're useful. I don't think anyone does anything like this. So it's not the... I don't know. It's honestly... I haven't figured out a way to, like... Just doing it more and more, I can explain it, what I'm doing a little bit better and a little bit cleaner. So this is kind of a couple days in, and we're doing a lot better job of kind of getting there a lot faster. But for sure, you want to know where these approximations come from. I'll just end with sine and cosine, because if you're going to draw the sine and cosine graphs, always do this. You're going to do, just do thirds. If you do this in thirds, you're just good to go. So we got 30, 60, 90, and then you're going to come up. And then I would do this box. It makes sense because your slope is going to be 1. This is going to be the sine graph. And so this is going to be 0.5. This is going to be 1. Well, hell yeah, you're going to hit 30 right there. And for a small angle, we're going to say, well, hell yeah, even 60 we're going to hit right there. So this is going to be sine. And, it actually just goes like that. But there's only 15% error. So for just rough guessing, like, oh, hell yeah, like 15% is just fine by me. And so it really shows you that, hey, small angle can go up all the way to 60, and then you're just at 1. All right, and then the cosine, same thing. Just divvy out 3. So you have 30, 60, 90. And then same thing. Probably do a box here just to make sure that's nice and square. That wasn't very square. We're running out of room. But hell yeah, cosine, you're going to go, this slope is still a slope of 1. So you're hitting the halfway point at 60. Sorry, I'm not drawing this very good. But hell yeah, so there's going to be your cosine graph. Cool. So this is sine and cosine. But that's basically, yeah, that's the, this actually doesn't even have anything to do with radians. You're just linearly approximating, You're saying that, hey, I have a slope from the get-go, and this slope really doesn't change within the first 30 degrees. And so, yeah. Alright, hell yeah, but this is going to trip me up though. You really want to do this with radians. To get to 90, that's going to be pi divided by 2, and then you got to divvy pi divided by 2 into 3 parts. So you're going to have pi 6 here, you're going to have 2 pi 6 or pi thirds there. And is that even right? Because you'll have 3. 1 pi 6, 2 pi 6, and then 3 pi 6, it's a half. Hell yeah. But if you do that, then your slope here is a slope of 1, and then you'll reach 0.5, and that's because, why is that? Alright, hell yeah, I gotta throw in the towel on that, but just by mentioning it in this video, it's something, I gotta throw some asterisks on the page, at 30 degrees, you will go through 0.5, because that's at 30. But 30 degrees in radians, pi divided by 6 is 0.5, I think it's like 0.51 radians, So if we have pi divided by 6, 0.52, so that's 0.523 radians. And so that's it. So if this is your slope, that you're going to be for every 2 pi, yeah, so for every pi thirds radians, pi divided by 3, I think that's your slope. Your slope is 1.04. Is that right? Something's up there. But anyway, but hell yeah, because this graph doesn't go above that line. It's tangent with this, has a slope of 1 right there. And then at 30 degrees, it hits this 0.5 and then continues dipping. But hell yeah, if this slope continued, it probably would not hit 1 up here. It would, well, yeah, I don't know where I'm going wrong on that, but close enough, you know what I mean? Anyway, sweet. So yeah, there's sine graph, there's cosine. Just make sure to divvy your graph up into thirds, you know what I mean? First thing to do, divvy it up into thirds and then do half and 1. And it does make sense. So 1, 2, 3. And then if you make this kind of a square box, because then you can say, hey, this is 0.5. And then you can see the slope of 1 for sine. And then we'll do the same thing for cosine and then kind of end the video. But hell yeah. So you just want to make sure. I mean, if you do this square, then you can kind of see that slope of 1. Cool. So there's cosine. And cosine is basically 1 from cosine of 0 to cosine 30. Stays way up there and then drops. But hell yeah, there's your 15% error. Pretty close. And then you get definitely a deviation right around 60 degrees, right around 30 degrees for cosine. Alright, hell yeah. Thanks for joining me. And that's a video.